Okay. And if you have a question at any point, feel free to type it in. Or if you're in the classroom, call it out. We'll gladly take any questions. So part one of today is just showing you the proof the other day on Friday that I didn't have typed up for you, the rectangle. Okay. Basically, this is just everything written out for you. If you'd like, rectangle DE, it should be DEFG, not DEGF. Okay, but it should be DEFG. And then you use angle G is congruent to angle F. Definition of rectangles: the rectangles are equal angular. DG is congruent to EF because they're opposite sides. Properties of parallelograms. Before you take your quiz on this, which will be next week after quarterlies, we will walk through proofs and the different rules that apply to different types of proofs. Then FG is congruent to FG. That is the shared side. The two triangles are on top of each other. DGF is congruent to EFG. All right, by side angle side, not hypotenuse leg. We talked about that on Friday. And then finally, DF is congruent to EG, which tells us the diagonals of a rectangle are congruent. Again, we will talk about proofs next week you take that quiz. Okay, so there we go. All right. And like I said, if you want to ask any questions, feel free to type them in on that side note. All right. And we'll go from there. Okay, so now we're going to talk about honors problems. And when we mean honors problems, we're talking about problems that go beyond the homeworks. The two homeworks are up for 6-4 and 6-5. They're due next Monday. They don't have to be done this week because it's quarterly week. But if you are going to focus on your quarterlies, those will need to be done over the weekend and submitted by Monday. Those are covered by the notes we did in class last week. These are the types of challenging problems that separate you guys from the other geometry students in school. All right. So basically what this is going to break down to is there's two things you got to worry about. Okay, there's two things you got to worry about. The first of which is right triangles. All right, because a rectangle is made up of right angles, because a rhombus has diagonals that are perpendicular, you need to worry about right triangles, which means we could be involving PT, which of course stands for Pythagorean theorem. It could be SRT, special right triangles. So 30, 60, 90s and 45, 45, 90s. And finally, it could also involve trig. And we'll go through how you know it's that. And then we're going to talk about more advanced algebra problems, which means possibility of systems and the possibility of quadratics. Okay. All right. So we start with, it says, given rhombus felt whose diagonals measure 18 and 30 centimeters. So it doesn't tell us anything about angle measures. So that tells us we can put the F, the E, the L, and the T in anywhere we like. However, they do need to be consecutive vertices. Does everybody understand that? Okay. Now, that one piece of information they give you is the diagonals. So it's probably going to make sense. It's probably going to make sense for us to draw in the diagonals. Okay. So I draw those in. And depending upon how you want it to be, you can draw it to scale or not to scale. It's not going to affect the problem. It says the diagonals measure 18 and 30 centimeters. Well, you have to remember that a rhombus is a parallelogram. And that for a parallelogram, the diagonals bisect each other. All right? So that means half of 18 is 9 and half of 30 is 15. Everybody good thus far? All right. Well, one of the things that makes a rhombus is the diagonals are perpendicular. So I put the right angle in at the point of intersection. All right. I put the right angle in. They give me two sides of a right triangle. That tells me I'm going to use Pythagorean theorem. Okay. I'm going to use Pythagorean theorem. 9 squared plus 15 squared equals S squared, S standing for the side length. 9 squared is 81, 15 squared is 225. Add them up and we got 306. And then finally, to undo the square, we do a square root. And the square root of 306 is going to be 3 root 34. Everybody good with that part of it? Okay, so then we have to make sure we answer what they asked for, and they asked for the perimeter. All right, so if the side length is 3 root 34, you then have to remember that all sides of a rhombus are congruent. That's what makes it equilateral, so we can multiply by 4. And that gives us our final answer of 12 root 34 centimeters. All right, so 12 radical 34 is going to be our final answer. Okay. All right. So this is what I would like you to do. Take 90 seconds to set up what you need for number 2. Take 90 seconds to set up what you need for number 2. Got about 45 seconds left, guys. All right. Okay, so hopefully everyone at least has the consecutive vertices labeled in the right place. It's not going to matter if you have them in a different place. Just make sure your S goes to your P and your R and so forth. Otherwise, it's going to mess up your final answer. All right, so basically there's my rhombus. And all my sides are 10 centimeters. Everybody good with that? All right, now they want us to find the length of each diagonal. Well, that would be helpful if we drew them in. And then you have to remember the other property of parallelogram or rhombi, and that is, oops, didn't want to do that. All right, and that is that the diagonals bisect the angles at the vertices. So if angle P is 60 degrees, then this angle is 30 degrees. Everybody good with that idea? Well, instead of Pythagorean theorem, because I only have one side, but I have 30 degrees, I'm going to use special right triangles. You have to remember that the hypotenuse is double the shortest leg. So working backwards, we're going to cut it in half, and that's 5. And then the longer leg, not the hypotenuse, is the shorter leg, root 3. So that one is 5 root 3. That other part of the diagonal is 5 root 3. And then that would be 5. All right. 5 root 3 plus 5 root 3 makes one of the diagonals 10 root 3. 5 and 5 is 10. So the other diagonal would be 10. The difference is they give me specific angle measures. which enables me to know which one is which. In other words, the 10 root 3 would be diagonal PR, and then the 10 would be diagonal SA. All right? Everybody good with that? Okay. Number 3, given rhombus plumb, where the measure of angle L is 44 degrees and the measure of diagonal UP is 18 centimeters. To the nearest tenth place, find the length of diagonal LM and side length of the rhombus. All right, so a couple things. Number 1, the angle measure is 44, which is a great number, but it isn't 30, 45, or 60, which means special right triangles are out. Number 2, they're telling me to round to the nearest tenth place, which makes me believe, all right, that I am going to use trigonometry. So I start by drawing rhombus plumb. All right, I'm going to put the L down there since it's 44 degrees, and then place everything else where it needs to be. So I got rhombus plumb. Okay. So I draw in the diagonals. And you got to remember, like I said, the diagonals bisect the angle. So this is 22 degrees. Diagonal UP is 18 centimeters, and you got to remember it's bisected. All right? So each of those is 9. Okay? Now, it wants diagonal LM. So that's going to help me with that. So I'm going to call it X. And it wants the side length Y. So that's going to help me over there. All right. And we're going to remember that this is a right angle always in a rhombus. Okay. So X is the adjacent, 9 is the opposite. That's tangent. So tangent of 22 equals 9 over X. Tangent 22 equals 9 over X. At the end of the day, when I'm doing this problem, I'm going to end up... Calculator. Calculator. All right. So tangent 22 equals 9 over X. I'm going to end up dividing 9 by tangent 22. Makes that 22.3 if I round to the nearest tenths. Y is the hypotenuse. Again, 9's the opposite, so that's sine. So sine 22 equals 9 over Y. Once again, since the variable is in the denominator, I'm going to divide 9 divided by sine 22. And I get 24.0. All right. Now remember, LM, the 22.3 is only half of it. L to M goes all the way. So that's the 22.3. So we got to multiply by 2. And when I multiply by 2, I get 44.6. And the side length of the rhombus would be 24. All right. Any questions about trigonometry, special right triangles, or regular Pythagorean theorem? How do they apply to these problems? Okay, so then let's move on to the last one, which is the biggie. It's got a lot going on. All right, so we're looking at it, and it says, given rhombus able with diagonals intersecting at point X in the following: 4x plus 2, y plus 12, negative 4y, 2x plus 4. Hopefully you recognize we have two different variables, which is telling me we're going to dabble a little bit in systems. All right. So we start by drawing it out to give us some structure. All right. A, B, L, E. All right. And they intersect at X. All right. So that's bisected and that's bisected. So AX equals XL and BX equals EX. All right. If I start with the AX equals XL and substitute the variables, y plus 12 equals 2x plus 4. Since the y has no coefficient, I'm going to isolate the y. So y equals 2x minus 8. So y equals 2x minus 8. I'm going to use substitution for this. If you want to use elimination, feel free. All right, bx is negative 4y, and ex is 4x plus 2. Everybody good? Okay. So I can take that equation y and substitute for y in the other one. That's what substitution is all about. So now I'm going to have negative 4, 2x minus 8 equals 4x plus 2. I'm going to distribute negative 8x plus 32 equals 4x plus 2. All right, I'm going to bring the negative 8x over there by adding 8x. I'm going to bring the 2 from the right to the left by subtracting. When I'm done with that, I'm going to have 30 equals 12x. Dividing by 12, x is 2.5. All right, to get y, I'm then going to substitute that in. So y equals 2 times 2.5 minus 8. 2 times 2.5 is 5. 5 minus 8 gives me negative 3. All right. So I'll start with EX. 4x plus 2. All right. Becomes 4 times 2.5 plus 2, which gives me 12, which means BX is also going to be 12. AX, which is y plus 12, becomes negative 3 plus 12, which is 9, meaning AX is going to be 9, and if I needed it, XL is also going to be 9. Okay. Remember, these are always right angles on rhombi. All right. So now Pythagorean theorem kicks in, or triples, depending upon what you remember. All right. 9 squared plus 12 squared equals the side length squared. 9 squared is 81. 12 squared is 144. 144 plus 81 is 225. And the square root of 225 is 15. Makes the side length 15 like they asked for. And the perimeter 4 times 15, which is 60. All right, you can label both of those with units since they don't really give you one. So that's the first part. The second part asks for angle measures. So what I'm going to do is I'm going to take this triangle there and transfer it out of there, draw it over here. This is 12. That's 9. E, X, and A. All right. I'm trying to get this angle. Right now I have the opposite of the adjacent, which means tangent. So tangent of E equals 9 over 12. So you're going to go to your calculator and hit second tan, and then enter 9 over 12. And you're going to end up with 36.9 degrees. All right. However, when you come back to your diagram, realize, please, that the 36.9 is just that angle. And those angles are bisected, so that portion's also going to be 36.9. So that means, in fact, angle E is going to be the 36.9 times 2, which gives me 73.8. So angle E is 73.8 degrees. And so is angle B, because they're opposite angles. So E and B are both 73.8. And then from other properties of parallelograms, consecutive angles are supplementary. So to get angle L, I just have to subtract 73.8 from 180. That gives me 106.2. And again, since opposite angles are congruent, angle A is also going to be 106.2. All right. Tomorrow, we will do the rectangle part and square part, which is the remainder of this. All right. The rectangle and square part. Oh boy. Didn't bring the square part, so I guess we're going to do that on Thursday. All right. So tomorrow we will do the rhombus part. All right. Now, okay, what you need to start thinking about doing, all right, this is what we're going over tomorrow. All right. So tomorrow in the quarterly review, we're going through, I believe, let me count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we will probably get through to number 12 tomorrow. So the plan is to go through 1 through 12 on the quarterly review. All right. And then after that, we will handle the rectangle section of what we're just working with. Okay. So you got about 15 minutes. My suggestion is, if you haven't done 1 through 12 in the quarterly review, start with that. If you've completed the quarterly review, then you can go back and work on the rectangle section to start preparing you for tomorrow. Either way, I will stay here for the remaining time you guys are in class if you have any questions. If you're good and you're home, you can take off, and we will meet you back here tomorrow, same time.
All right. See you tomorrow.
Have a good day, guys.